To get regular videos like this, like, share, and subscribe to our channel. Stay connected with us.
Welcome to our state-of-the-art facility, where we integrate robotics and human precision to build the next generation of commercial aircraft.
Our journey begins with the arrival of high-performance alloys, specifically selected for their extreme durability and lightweight.
Every material is digitally cataloged and stored in climate-controlled zones to maintain structural integrity from day one. Non-destructive testing ensures that no microscopic flaws exist within the metal before it enters the production line. Precision CNC milling transforms solid blocks of alloy into intricate structural ribs with micron-level accuracy. Fiber lasers cut through fuselage panels with unparalleled speed, creating the apertures for windows and doors. Shot peening strengthens the metal surface, enhancing fatigue resistance for decades of flight cycles. Anodizing baths create a protective oxide layer, shielding the aircraft structure from the elements and corrosion. Advanced composite tape layers build up the aircraft's skin, layer by layer, for maximum strength at half the weight of metal. Skilled technicians manually refine complex joints, ensuring the composite material conforms perfectly to the aircraft's geometry.
Vacuum bagging eliminates air pockets, ensuring a flawless bond between every layer of the composite structure.
Intense heat and pressure inside the autoclave bake the resin, curing the composites into a single, incredibly strong piece. Post-cure inspection uses advanced ultrasound to verify that the internal structure is 100% free of voids or delamination. Subassembly begins with the skeletal frame of the nose, precisely aligned in massive circular jigs for structural integrity.
Does the blueprint match the slot tolerance here?
Yes, proceed with the temporary fasteners.
Aerospace-grade skins are now meticulously applied, forming the aerodynamic shell of the cockpit section.
We need another 2 millimeters on the starboard side.
The laser alignment looks good here. Sending the specs now.
Check the crosshair alignment on section 3.
It's holding steady right on the mark.
Pressure looks good down here.
The mid-fuselage takes shape as structural frames are aligned with laser precision to form the main cabin body. Automation accelerates production as robotic riveters install thousands of fasteners with absolute consistency. The rear fuselage is engineered to house the tail stabilizers and support the critical pressure bulkhead. This reinforced dome is the final barrier, maintaining cabin pressure against the extreme vacuum of high-altitude flight.
The aircraft's body comes together in the major mate process, where massive sections are joined into a single, unified hull.
The center wing box is the aircraft's strongest component, engineered to carry the entire load of the wings during flight.
The center wing box, the structural heart of the plane, is assembled. This box will sit in the middle of the fuselage and support both wings. Long-range wing spars are processed on massive longitudinal lines, forming the backbone of the aircraft's lift surfaces. Skins are temporarily fastened to the wing frame, ensuring a perfect fit before final robotic integration.
Lower the skin slowly.
Copy, slowly lowering.
Pin engaged. Moving to the next one.
Make sure that skin is flush. It's tight, ready for the gun.
Precision is paramount in the tail stabilizers, where control surfaces must move with effortless accuracy.
Miles of complex electrical harnesses are routed throughout the hull, forming the aircraft's critical nervous system.
Okay, pull it through slowly. Got it. Securing this section now.
We need to secure this section before the next beam. Every 12 inches, right?
High-pressure hydraulic systems are integrated to provide the immense power needed for flight control and landing systems.
Thermal and acoustic insulation blankets are installed, transforming the cold metal hull into a quiet, climate-controlled cabin.
Carbon fiber floor grids are secured, providing the foundation for the cabin interior and passenger seating.
Precision electronics and high-definition avionics are integrated,
giving the pilots total control over every flight parameter. Interior sidewalls are fitted with millimetric precision, creating a seamless and aesthetically pleasing cabin environment.
Seating systems are securely anchored to the floor tracks, completing the passenger accommodation phase. The wings are integrated with the fuselage in a high-precision maneuver, creating the primary structural lift assembly. Robust landing gear systems are installed, engineered to withstand the immense impact forces of repeated landings.
Easy now, easy! Alignment is good.
Send the pin home. Hold it steady right there. Secure the main coupling. Retraction sequence engaged and locked. Good job, everyone.
The vertical stabilizer is mounted, providing the directional stability necessary for safe flight operations.
Easy down, we are aligned on the forward lug.
Copy that. Holding steady.
Bolt 1 seated.
Clear on the left, steady descent.
Roger, confirmed seating. Engaging torque wrench now.
Engine pylons are attached to the wing spars, providing the critical link between the airframe and its power plant.
Massive turbofan engines are integrated into the wing pylons, providing the thrust needed for global travel.
Okay, bring it up 2 millimeters.
Confirmed, coming up slowly.
Alignment looks good on screen 3.
For the first time, the aircraft is powered on, initiating a series of comprehensive digital system diagnostics.
Advanced robotic spray systems apply the final livery, protecting the airframe and representing the airline's brand.
Every moving surface is tested to ensure immediate and reliable response to pilot commands.
High-speed brake tests ensure the aircraft can stop safely under any landing conditions.
The final result of thousands of hours of precision engineering, the aircraft takes to the skies, ready for decades of global service.